All right, let's get into it. We're going to take a journey to understand the magic that happens behind the scenes every single time you look up a website. It's one of those systems that works so fast and so flawlessly, we pretty much take it for granted. But under the hood, there's this fascinating, massive address book that makes the entire internet tick. I mean, it seems so simple, doesn't it? You type a name, you hit enter, and poof, a website appears. But that one little action, it kicks off this incredible, super fast scavenger hunt across a global network. See, your computer has a name, but what it really needs is a number, an IP address, to actually make a connection. So the big question is, how on earth does it find it?
Well, that's where the domain name system, or DNS, comes in. And it's really built to answer two fundamental questions. The one we use all the time is a direct query. Hey, what's the IP number for example.com? But it can also go the other way with a reverse query. I have this IP number, what's the name that goes with it? And that reverse lookup is actually super useful for things like network troubleshooting or even figuring out if an email is coming from a legitimate source.
So who's in charge of all this information? You might think it's some giant supercomputer sitting in a vault somewhere, but nope. The answers are held by a whole team of servers we call the keepers of the map. The whole system is built from the ground up for one thing: reliability. I mean, think about it. You can't have one server going down and breaking a huge chunk of the internet. That would be chaos. So the entire DNS system is designed to be incredibly resilient, with tons of backups spread all over the world. So why not just have one big server with all the answers? Well, it all comes down to that reliability we just talked about. We need a whole network of servers to provide redundancy, to act as backups, so that if one fails, others are just ready to step in. Plus, spreading the workload all over the globe makes everything so much faster for everyone. And the way this works is actually pretty clever. It's a classic master and copy setup. You have the primary server, which holds the original editable master list for a domain. If you need to make a change, you do it there. Then you have all these secondary servers, and their only job is to hold a read-only copy that they get from the primary. This makes sure the correct information is everywhere and always available. Okay, so we've got the players on the field. Now, let's actually follow a single request from start to finish. Let's go on the hunt for an IP address and see the journey it takes. This whole process is designed to be as efficient as possible. It's always looking for the easiest, closest answer first. So, step 1, your computer checks for a quick, local answer in its cache. If it comes up empty, it forwards the request on. And only as a last resort does it go all the way to the official source, the authoritative server that holds the master record. Let's talk more about that first step, the cache. You can think of a caching server as a cheat sheet. It's not the official source for any domain, but it has this fantastic short-term memory. It remembers the answers to recent lookups. So if you or someone near you just asked for the same website, the answer's already right there, making the response practically instant. But what happens when that cheat sheet is blank? What if the shortcut isn't there? Well, now our query has to travel a little farther. It has to find its way to the actual source of truth, that authoritative server we mentioned earlier. And this is where those authoritative servers are so important. To make sure all the copies of the map are the same, they have a special process called a zone transfer. This is basically just the primary server regularly sending out the latest version of its address book to all the secondary servers, making sure every copy is perfectly up to date. Okay, so our query made it, it's found the right server. But what are we even looking at? What does this database that holds all these records actually look like? And this, right here, might be the most surprising part of this whole thing. You'd probably expect some super complex, heavy-duty database, right? Nope. It's just a simple text file. Seriously, the entire address book for a slice of the internet is stored in a basic text file. That's it. Now, to keep things from being a total mess, every single line in that file has to follow a very strict format. Each line is called a resource record, or RR, and it's like the grammar rules for the internet's address book. This structure is what allows computers to read the map so quickly without getting confused. All right, so let's put on our detective hats for a minute. Let's actually take a real-world example from one of these files and break it down piece by piece. Here we go. Here is a standard resource record. I know it might look like a line of code or just a bunch of gibberish at first, but I promise, once you see the pattern, it all makes perfect sense. Let's decode it. First up, the owner. This part is super simple.
It's just the name of the thing we're looking up. In this case, the record is all about the domain obelix.acier.es. Next, you've got this number, 7200. This is the TTL, or time to live. Think of it like an expiration date on a carton of milk. It tells all those caching servers, hey, you can remember this info for 7,200 seconds, which is 2 hours. But after that, you better come ask me again, just to make sure nothing's changed. Okay, next is the class. You'll almost always see N here, which just stands for Internet, no big mystery. Then we have the letter A, that's the record type, and A tells us it's an address record. And finally, we get to the whole point of our search, the R data. That's the information itself, the actual IP address we've been hunting for this whole time. So let's just take a quick step back. We have followed a single request on its incredible journey from your keyboard through a global network that is built for speed and reliability, all the way to a single line of text in a simple file. Pretty cool, right? But that brings up a really interesting final thought. This whole gigantic worldwide system, it all boils down to the accuracy of these simple little text files. So that leaves us with one last question to think about. In a system this massive, what happens when the map is wrong? What are the consequences when that one simple line of text leads us to the wrong place entirely?